Bismillahirrahmanirrahim. Assalamu alaikum, students. Welcome to the new lesson, that is lesson number 14 of the Unit 3 logarithms. In the previous exercise, we learned about the ordinary and the scientific notation. Now, these logarithms are also related with that ordinary and the scientific notations. Now, what the logarithms are and why we use them. The logarithms are useful tool for the accurate and rapid computation. Logarithms with the base 10 are known as the common logarithms, and those with the base e are known as natural logarithm. We shall define the logarithms with the base a greater than 0 and a is not equal to 1. अब लॉगरिथम ये क्या कह रहे हैं कि हम यूज क्यों कर रहे हैं? बेसिकली बड़ी बड़ी कैलकुलेशंस के लिए को तेजी से करने के लिए, उनको एक्यूरेट आंसर फाइंड आउट करने के लिए हम लॉगरिथम्स यूज करते हैं. दो तरह के लॉगरिथम्स हैं, एक बेस 10 के साथ जिसे हम कॉमन लॉगरिथम्स कहते हैं और एक बेस ई के साथ है जिसे नेचुरल लॉगरिथम कहा जाता है. हम यहाँ पे लॉगरिथम्स को डिफाइन करेंगे जहाँ पे बेस जो है वो ए ग्रेटर देन 0 होगा और इक्वल 1 के इक्वल नहीं होगा. अब आप देखो logarithm of a real number. If a raised to power x is equals to y, so this is the exponential form of anything, that just like 3 raised to power 2 is equals to 9, then x is called the logarithm of y. Look here, a raised to power x is equals to y. This is basically the exponential form of y. When we will read it in the logarithm, then we will say that this x is called the logarithm of y to the base a. This x is the logarithm of y when the base is a, and it will be written as log of y to the base a is equal to x. Now look at the ways that how we will read them, how we will write them. This is the exponential form a raised to power x is equals to y. We will read it as a raised to power x is equals to y. Now, in the logarithm, we will read it like that this x is the logarithm of y with the base of a. And we will write it as log of y to the base a is equals to x, where this a is greater than 0 and a is not equal to 1, and y is also equal greater than 0. It means that the logarithm of a number y to the base a is the index x of the power to which a must be raised to get the number y. जैसे हम यहाँ पे कहते हैं कि a की क्या पावर y की इक्वल होगी, as it is ये स्टेट ये लाइन दे, ये भी इसको कहती है कि the logarithm of a number y, इसको जब आप पढ़ेंगे, the logarithm of a number y to the base a is the index x of the power to which a must be raised to get the number y. Now this the relation a raised to power x is equals to y, and log of y to the base a is equals to x are equivalent. These are equivalent. When one relation is governed, it can be converted into the other. हम बेसिकली यहाँ पे यही काम करेंगे कि हम जो गिवन रिलेशन होगा उसको दूसरे में कन्वर्ट करके इजीली हम उसको उसमें अननोन्स को फाइंड आउट करेंगे. तो इसी बात को ये जो लिखा है कि रिलेशन a raised to power x is equals to y and log of y to the base a is equals to x are equivalent. When one relation is given, it can be converted into the other one, just like here. A raised to power x is equals to y. It may be written, when we will write it in the logarithmic form, it will be log of y to the base a is equals to x. These are equivalent relations. These two relations are equivalent relations. This, the first one, and this is the second one. These are called the exponent and the logarithmic forms of the same solution. This is the exponential form. This is the logarithmic form. We may write this exponential form into the logarithmic form and the logarithmic form into the exponential form. Now look at this one. Take an example for this. To explain these remarks, we observe that 3 raised to power 2 is equals to 9 is equivalent to the, हम इसको logarithmic form के अंदर लिखने लगे, log of 9 to the base 3 is equals to 2. Log of 9 to the base 3 is equals to 2. Now, these are two equivalent forms. Here, 2 raised to power minus 1 is equals to 1 over 2. This is the equivalent to log of 1 over 2 to the base 2 is equals to minus 1. Similarly, we can say that log to the base 327 is equals to 3 is equals to. Now, this logarithmic form will vary it into the exponential form, that 27 is equals to 3 raised to power 3. Now, the logarithm of a negative number are not defined here in this at this stage. We will just learn about the logarithm of positive numbers. Now here example that find log of 2 to the base 4, that is find the log of 2. ये इसको पढ़ने का तरीका बताया कि find the log of 2 to the base 4, log of 2 to the base 4. Now solution. Let this given form log of 2 to the base 4 is equals to x. Now this is the logarithmic form as we learned in the previous slide. Now first we will write it in the exponential form. In the exponential form we will write them 4 raised to power x is equals to 2. 4 raised to power x is equals to 2. Now here 2 raised to power 2x, this 4 raised to power x will be converted into 2 raised to power 2x is equals to. This 2 may be written as 2 raised to power 1. Now these bases are same, so we will write them 2 raised to power x is equals to 1 and the x will be equals to 1 over 2. As we wrote that x is equals to log of 2 to the base 4. So now the value of x is equals to 1 over 2. It means that log of 2 to the base 4 is equals to 1 over 2. This was an example. Now these are some definitions of the logarithm जिसे हमने define किया हुआ है, just आप इसको use करेंगे कि a raised to power 0 is equals to 1, log of 1 to the base a is equals to 0, and log of a raised to power 1 is equals to a, and log of a raised to the base 2 is equals to 1. These are the rules we have already learned, so we converted them into the logarithmic form here, that if log of 1 with any base will equals to 0, and here that if log of the number to the base of with the same number, that will be equals to 1. Now we will do some questions of the exercise. Now here the question number 4, 5 and 6 are related with that. I am going to do these 3 questions which are related to these laws. What replacement for the unknown in each of the following will make this statement true? Log of 81 to the base 3 is equals to L. So here we are asked to find the value of L. Log of 6 to the base A is equals to 0.5. We will find the value of A here. Log of n to the base 5 is equals to 2. Here, and 10 raised to power p is equals to 40. Now look, I am going to do the first one, that is log of 81 to the base 3 is equals to L. Now first of all, I will write this logarithmic form into the exponential form, so it will become 3 raised to power L is equals to 81. 3 raised to power L is equals to 81. Now you know that 81 is equals to 3 raised to power 4. Our target will be to convert to write the same base on both sides of this exponential form. So it will become 3 raised to power L is equals to 3 raised to power 4. So bases are equal, so L is equals to 4. It means that here the value of L will be 4. These are as simple as they are here now. Now question number 2 and 3, you will solve these parts by yourself. 10 raised to power p is equals to 40. Solution 10 raised to power p is equals to 40. Now changing into the logarithmic form. The logarithmic form is P is equals to log to the base 10 equals to 40. Now this log to the base 10 is called natural base, so it will be written as log 40. And when we will use the calculator to find this, you will see that the value of the log 40 is equals to 1.6021. Now look at the second one. Evaluate log of 1 over 128 to the base 2 and log of 512 to the base this one. Look here. Log of 1 over 128 to the base 2. This. Suppose that this is equals to x. Now we will write it in the exponential form. 2 raised to power x is equals to 1 over 128. Now this 128 will be written as 2 raised to power 7. So it becomes 2 raised to power x is equals to 1 over 2 raised to power 7. Now this 1 over 2 raised to power 7, this will be written as 2 raised to power minus 7. Now the bases are same, so x is the exponent will be equal, so x is equals to minus 7. So it means that log of 1 over 128 to the base 2 is equals to minus 7. Now look at this. This log of 512 to the base 2 under root 2. This will be written as this one. Log to the base, log of 512 to the base 2 under root 2 equals to x. Now write this in the exponential form, you will get 2 under root 2 whole raised to power x is equals to this one. Now this 512, this is equals to 2 raised to power 9. Now 2 raised to 2, when we will separate them, it will become 2 raised to power 1 dot 2 raised to power 1 over 2. When we add these two powers, then it will become 2 raised to power 3 by 2. 1 plus 1 over 2. Now this will become 2 raised to power 3 by 2 x is equals to 2 raised to power 9. The bases are same. So 2 over 3x will be equals to 9. 2 over 3x will be equals to 9. And here, x will be equal to 9 multiplied by 2 over 3. So after simplification, we will get that x is equals to 6. Therefore, log to the base 512 to the base, log of 512 to the base 2 under root 2, that is equals to 6. Now, part 6. Again, यहाँ पे भी यही चीज़ exponential form, logarithmic form. यहाँ पे भी एक पार्ट जो है वो मैं सॉल्व कर देता हूँ, बाकी आप कर लीजिएगा. इससे इस पार्ट को देख लें. Log of 8 to the base 64 is equals to x over 12. Right in the exponential form, we got 64 raised to power x over 2 is equals to 8. So now here we have 8. So 64 will be written as 8 raised to power 2. Now these two will be cancelled and we will get x, 8 raised to power x is equals to 8. Now the bases are same, it means that x will be equals to 8. So the value of x is equals to 8. Now these two questions are covered, 3 questions are covered in this lecture. Basically, this is that how you will convert the logarithmic form into the exponential form and the exponential form into the logarithmic form, how you will read them and how you will find the unknowns. So the remaining parts, you will solve them by yourself and then you will do them in your neat notebooks. Then some of the questions we will give you as an assignment, so you will do them and you will send their images as your assignment in the PDF form. So thank you. I will do the next questions, question number 1 and 2 in the next lesson. And have a nice time. Thank you very much. Allah Hafiz.